All right, guys. Sorry I'm not there again today, but we're going to go ahead and start something new. We're going to start remembering, and I can't remember if we have explicitly taught this, but we're going to do simplifying expressions. I think last year we talked about it a little bit, but we're going to add on to what we had last year onto this year. So an expression is a mathematical phrase that can contain numbers, variables, and operators like addition and subtraction. Okay? An expression does not have an equal sign. Okay? So an expression, it does not have an equal sign. As soon as there's an equal sign, it becomes an equation. Now we'll see lots of examples of expressions, so don't worry if you don't understand it so far. Okay? A term is a constant. A constant is just a number without a variable, or a variable in an expression. And terms are always separated by plus and minus signs. So an example is, let's say that I had the expression 6x plus 2r. This would be an expression, no equal sign. A term would be 6x. Another term would be 2r. Okay, those are examples of my terms there. The coefficient is the number in front of a variable. I know that's a word I taught you guys last year, was coefficient. So in this example, a coefficient would be 6, or a coefficient would be 2. It's not the variable, it's not the variable and the number, it's just the number in front of the variable. That's the key on that one, the number. And then the last one, like terms, must have the same base, and the base is variable, or the same exponent or power. So things that are like have the same base, meaning they don't have a variable, or they do have a variable and their variable has the same power. All right, let's go ahead and label the different parts of this expression right here. So this expression is 4D take away 9. D is what we would call the variable. That's the easiest part. It's the letter. Okay. 4, the number in front of the variable, is the coefficient. Okay. The number on the end, now this one doesn't have a variable, so this is what we call the constant. The subtraction sign is an operator. We would consider 4D a term, and then all together 4D take away 9 is an expression. Remember, if you need the sub to pause at any time for you to copy down this stuff, go ahead and tell them. All right, going on, give an example of an expression with 3 terms. So you can try and write your own. If I were to write one, I would write something like 5a take away 7x to the 5th power, because you can throw a power in there, plus 2m, something like that. Okay, that has 3 terms. Ta-da! This next one wants us to list all the terms. So remember that the term includes the sign in front of it. So 8c is a term. Okay, my next term would be minus 5 or negative 5. My next term is a positive 4c, so we don't need to write the positive sign, 4c squared. Just like we normally write just 5 as a positive 5. It's only when a negative we include the sign. And then my other term is 2b. Notice that I'm separating my terms with a comma. When I'm listing out a list, I put commas in between the items. All right, the last one says circle the coefficients in the expression. Remember that coefficients are the number in front of a variable. So variable, number in front, 5. Variable, number in front, positive 7. No variable, so this is not a coefficient. But variable g, coefficient, -2. So it said just to circle them, but if I were to write a list, I would say I have a coefficient of 5, I have a coefficient of 7, and I have a coefficient of -2 or -2. All right, give an example of a term, of a like term for each of the following. So -50. Well, -50 doesn't have a variable, so I just need to give a number without a variable, like 20, or 200, or -11, or -2.5, or it just has to be something without a variable. Okay, the next one is 3b. Well, for it to be the same, it's going to need a b in it, and you just need to list something in front. -8. Okay, other right answers might be 10b, 100b, -70b, anything you want. Okay, you list one for C and D. I would say something like -8a if I wanted to. But you could do something else. And then this can be as simple as 4x squared. Just has to have an x squared. I want you to share with your neighbor what you got. Make sure that you're doing it right. Pause it, and then when you're ready, go ahead and go on. Okay, so here's our next one. Next one is talking about simplifying expressions. So we can simplify algebraic expressions by combining like terms. So things that look like each other. Be careful when you are combining terms to check for the sign that is in front of the term. The sign goes along with the term. So on this one, the Robinson family ordered some snacks from the state fair. They bought the following: D, drinks D, P, pizza, and ice cream cones C. Write an expression to represent their purchases. So let's list out what we see. I see a pizza P plus a pizza P plus a drink D and a drink D. Remember, I'm just using the variables that came from here. Okay, I see an ice cream cone C and a pizza P and another ice cream cone and then 2 more pizzas and then 1 more drink. Ooh, sneaking it in. Now, if we were to simplify this, or to kind of, because I wouldn't want to go to the front of a line and say, I need pizza plus drink plus drink. No, I would want to count up everything. So I would count that I have 1, 2, 3, 4, 5 pizzas. So 5 P's. And then I need 1, 2, 3 drinks, 3D. And then I need 1, 2 ice cream cones, 2C. Now part C says, explain how this example can relate to an algebraic expression. Well, in an algebraic expression, we only combine parts that are similar. So I would never go to the front of the line and say, I need 8 pizza drinks. Because first of all, that sounds disgusting. But what is a pizza drink? We don't sell pizza drinks. We sell pizzas or drinks. So I cannot combine those terms. And I cannot combine all of them to get a pizza drink cone. That's also disgusting. Okay, so our algebraic expressions cannot all combine. If they're not like these, they cannot combine. So I would say each term can only be combined with another like term. Okay, this meaning I can only combine A's with A's and X's with X's, or P's with P's, that kind of a thing. Okay. So one thing that helps people is to color code. So you can either color code or use shape to identify each term and combine the like terms. So if you would like to, I want you to go grab, let's say, 3 colored pencils. So pause the video if you're gonna go do it. Go grab 3 colored pencils. All right, assuming you have your colored pencils, I'm gonna walk you through the first one and then help you with the other ones. So I have, this one has used shape. So we have 14b plus 6b. Those go together. 14 plus 6 is 20. And then there is plus 8 minus 12. So those integer rules are not going to go away. So 8 take away 12 is -4. All right, so grabbing one of your colored pencils, I see J terms, so I'm going to circle all my J terms with one of my colors. I'm going to include the sign in front of that number. Now with a different number, I only have one number without a J. I'm going to put a box around it with a different color. So let's go ahead and combine those J terms. I have a 4.2, 6.7, and those are positive, so I'm going to add those two first. That gives me 10.9. Now from there, it says take away 5. Well, I know that 10 take away 5 is 5, so I'm going to have 5.9J. I have used these 3 terms. The only one left I have is a -5, so it gets to hang out on the end. Does not combine. Okay, let's go to the next one. I want you with one of your colors to circle all of the C terms, including the sign in front. Notice I'm circling that plus. And with a different color, I want you to box the D terms, including that sign. With my C terms, I see I have 20C plus 10 more C, which is 30C. And over here, I see I have 8D take away 5D. And I know that 8 take away 5 is 3. So this gives me plus 3D. Okay. I want you to see if on your guys' own, you can try 5, 6, 7, 8. So just try them and check as you go. So if you want to do the first one and then check this and then the next one, however you guys want to do it and break it up, I'm going to give you a second for each of them and then just pause me as needed. Okay. 7A plus 8A is 15A minus 6, because there's a minus in front of that. All of these are D's, and I can put them in any order I want. So I like combining my minuses. So that gives me 8D in the front, take away 8D in the back. Hey, that's 0. And you can write 0 or 0D. Both are correct. Next one, 1.5 plus 6.5 gives me 8. -10, take away 3 more, negative 13. Last one. 1/2 h plus 2 wholes plus 3 halves. I'm going to add the fractions. And I know that 4 halves is the same as 2. So that's 2 h's. Plus 2 more, I haven't used those yet. 4 h's minus 1. Okay, example 9. Write and simplify an expression that represents perimeter. So remember that perimeter represents the outside of a rectangle or any shape. Okay, so I know that if this is 12y, that down here is 12y. And I know if this is 7.5, then this is also 7.5. So by combining my terms, 12y and 12y are like, and 7.5 and 7.5 are like. You can order these in whatever order you want. 12 and 12 give me 24y. 7.5 and 7.5 is 10. 14 plus 1 is 15, and our decimal comes straight down, plus 15. Okay, last one. The Jacksons earned $D in a garage sale last week. Their neighbors, the Thompsons, also had a garage sale and earned 35% more than the Jacksons. Circle any expressions that could be used to represent the amount of money the Thompsons earned. So we haven't talked about percents. So we're going to just skip this one. Let me double check and make sure there's none like that on your homework. Nope. Okay, on your homework, the first one says, Rebecca asked to create 5 pairs of like terms to determine if she completed the task. So make sure that all of them are like. Tell me yes or no. Circle which ones aren't. The next part is combining those like terms. And the last one is a perimeter, just like question 9. All right, you're going to do great, guys. Love ya.